Jupiter, the king of planets. It's a massive gas giant, the king of our cosmic neighborhood. This behemoth is striped with colorful bands of swirling clouds. Jupiter's sheer size boggles the mind. You could fit 1,300 Earths inside it. This isn't just any storm, it's a storm for the ages. First observed in the 17th century, the Great Red Spot has captivated astronomers for generations. Imagine peering through early telescopes, glimpsing this crimson eye staring back from the depths of space. With modern technology, we're finally starting to unravel its secrets. Our story begins in the 17th century. Imagine a time before electricity, before cars, before photography. Astronomers peered through rudimentary telescopes, sketching what they saw in the night sky. Giovanni Cassini, a renowned Italian astronomer, is credited with the earliest known drawing of a feature on Jupiter that closely resembles the Great Red Spot. Despite the limitations of early telescopes, astronomers were captivated by this unusual feature on Jupiter. They tracked its movements, noting its slow drift across the planet's banded atmosphere. The Great Red Spot, it seemed, was no fleeting phenomenon. As decades turned into centuries, the Great Red Spot continued to fascinate. Astronomers meticulously documented its size, shape, and color, noting subtle changes over time. The invention of photography in the 19th century revolutionized astronomy. Early photographs, though grainy by today's standards, provided valuable data for scientists studying this enduring storm. Scientists began to understand that Jupiter was a gas giant, not a solid planet like Earth. This realization led to new hypotheses about the Great Red Spot's formation. The dawn of the space age in the mid-20th century marked a turning point in our understanding of the Great Red Spot. The Pioneer and Voyager missions, launched in the 1970s, sent back breathtaking images of Jupiter and its Great Red Spot. For the first time, we saw the Great Red Spot as a dynamic, swirling vortex of clouds. These missions provided valuable data about Jupiter's atmosphere. So, what exactly is the Great Red Spot? It's a high-pressure storm, a colossal anticyclone. These winds whip around the spot at hundreds of miles per hour. The spot is embedded within Jupiter's turbulent atmosphere, a chaotic mix of hydrogen, helium, and other trace gases. But why is it red? That's a question that has puzzled scientists for centuries. One theory suggests that it's due to the presence of organic molecules called phosphine. Another possibility is that the red hue comes from complex chemical reactions involving sulfur or other elements. Imagine a kaleidoscope of colors constantly shifting and changing. That's what the Great Red Spot is like, its hue varying from a deep red to a pale salmon pink. These color variations are thought to be related to the storm's intensity and the altitude of the clouds within it. When the spot is particularly intense, its color deepens. Conversely, when the storm weakens, the colors fade. Jupiter's atmosphere is dotted with other, smaller storms, each with its own unique characteristics. The Great Red Spot, with its size and longevity, is the undisputed star of this cosmic ballet. The Great Red Spot has been raging for centuries, if not longer. How can a storm persist for so long? The answer lies in a delicate balance of forces. Jupiter's rapid rotation, coupled with the planet's internal heat, creates a constant source of energy that fuels the storm. Imagine a spinning top. As it spins, it remains upright due to the centrifugal force pushing outward. Similarly, Jupiter's rapid rotation creates a strong centrifugal force that helps to maintain the Great Red Spot's structure. This force, combined with the Coriolis effect, keeps the storm swirling in a relatively stable configuration. Recent observations have shown that the spot is shrinking, though it's still large enough to swallow Earth whole. The reasons for this shrinking remain a mystery. Despite its shrinking size, the Great Red Spot remains a formidable storm. It's a reminder that our solar system is a dynamic and ever-changing place. By studying this giant storm, scientists can learn more about the dynamics of planetary atmospheres. It's a window into the workings of gas giants, not just in our solar system, but potentially around other stars as well. In recent years, our understanding of the Great Red Spot has been revolutionized by NASA's Juno spacecraft. Juno's mission is to peer beneath Jupiter's swirling clouds, revealing the secrets of its interior. One of Juno's most remarkable discoveries is that the Great Red Spot extends far deeper into Jupiter's atmosphere than previously thought. Using its microwave radiometer, MWR instrument, Juno has been able to probe beneath the storm's visible cloud tops. These findings suggest that the Great Red Spot is deeply rooted in Jupiter's atmosphere. Juno's observations have also revealed surprising details about the Great Red Spot's winds. Using its JunoCam instrument, scientists have tracked the movement of clouds within the storm. These maps show that the spot's winds are even more complex and dynamic than previously imagined. At the storm's periphery, winds rage at hundreds of miles per hour, but as you move towards the center, they slow down dramatically. Juno's instruments have also detected powerful jets of ammonia gas rising from deep within Jupiter's atmosphere. While Juno has revealed much about the Great Red Spot's inner workings, it has also shown that this iconic storm is far from static. One of the most dramatic changes observed by Juno is the shrinking of the Great Red Spot's overall size. In the 1800s, the spot was estimated to be about 3 times the diameter of Earth. By the time the Voyager spacecraft flew past in the late 1970s, it had shrunk to about twice Earth's diameter. Today, it's closer to 1.3 times Earth's diameter. Scientists believe it could be related to changes in Jupiter's atmospheric circulation patterns. The Great Red Spot, despite centuries of observation and the recent revelations from Juno, remains an enigma. As we continue to explore Jupiter with missions like Juno, we can look forward to new discoveries that will further illuminate the secrets of this enduring storm. By understanding the forces that drive this giant storm, we can gain insights into the dynamics of planetary atmospheres. The Great Red Spot, in its swirling splendor, is a constant reminder of the wonders that await us as we continue to explore the cosmos. The Great Red Spot is more than just a pretty face on Jupiter's swirling canvas. It's a colossal weather system that's been raging for centuries. By studying its swirling patterns, its changing colors, and its interactions with smaller storms, we can learn a lot about how energy flows on a gas giant. Imagine trying to understand Earth's weather by looking at a single hurricane. It's a unique and extreme example of atmospheric dynamics, but it helps us understand the bigger picture. How does heat move from Jupiter's core to its upper atmosphere? The Great Red Spot holds some of the answers. It's like a giant natural laboratory where we can observe atmospheric processes that are impossible to replicate on Earth. What we learn from the Great Red Spot doesn't just apply to Jupiter. It has implications for our understanding of gas giants throughout the cosmos. By studying Jupiter's iconic storm, we're essentially creating a baseline for understanding similar features on other worlds. We can compare and contrast, looking for similarities and differences that can tell us about the unique conditions on each planet. The Great Red Spot is a stepping stone, a celestial Rosetta Stone that can help us decipher the secrets of gas giants across the galaxy. And it highlights the importance of studying our own solar system in detail, as it provides us with the tools and knowledge to explore the cosmos beyond. The story of the Great Red Spot is ultimately a story of human curiosity and our insatiable desire to explore the unknown. From the earliest astronomers who peered through rudimentary telescopes to the scientists analyzing data from the Juno spacecraft, we've been captivated by this swirling enigma for centuries. Each new observation, each new discovery has deepened our understanding of Jupiter and its place in the cosmos. The pursuit of knowledge about the Great Red Spot has driven innovation in telescope technology, spacecraft design, and scientific instruments. It's pushed the boundaries of what we thought was possible and inspired generations of scientists and engineers. And it's a reminder that the quest to understand our universe is an ongoing journey, not a destination. As we continue to explore Jupiter and beyond, the Great Red Spot will undoubtedly continue to intrigue and challenge us. Future missions might even send probes directly into the storm, braving its intense winds and turbulent atmosphere to gather even more detailed data. Whatever the future holds, one thing is certain: the Great Red Spot will continue to inspire awe and wonder, reminding us of the vastness and beauty of the cosmos we inhabit. Beyond Juno, the next chapter. Juno has revolutionized our understanding of Jupiter, but like all good missions, it raises more questions than it answers. As Juno's mission winds down, scientists are already planning the next chapter in Jovian exploration. Future missions will build upon Juno's discoveries, delving deeper into the mysteries of the Great Red Spot and Jupiter's dynamic atmosphere. One promising concept is a dedicated mission to study the Great Red Spot up close and personal. Imagine a spacecraft specifically designed to orbit the storm, monitoring its every swirl and eddy with unprecedented detail. Such a mission could carry instruments to measure wind speeds, map the storm's three-dimensional structure, and analyze the chemical composition of its clouds. Another exciting possibility is a multi-spacecraft mission, with probes strategically positioned around Jupiter to provide a global view of its atmosphere. By coordinating observations from multiple vantage points, scientists could track the movement of storms, study their interactions, and gain a more comprehensive understanding of Jupiter's atmospheric circulation patterns. It's like having a network of weather stations monitoring a giant planetary hurricane. Section 2. Unveiling the Depths Atmospheric Probes. While orbiting spacecraft provide invaluable data from above, there's no substitute for getting your hands dirty, or in this case, your instruments. Future missions could deploy atmospheric probes to plunge into Jupiter's swirling depths, braving the extreme pressures and temperatures to gather data from within the heart of the storm. Imagine a probe designed to withstand the crushing pressure thousands of times greater than Earth's atmosphere, enduring searing temperatures and powerful winds as it descends into the Great Red Spot's swirling abyss. This probe could carry instruments to measure the storm's internal structure, analyze its chemical composition in situ, and even search for signs of lightning or other energetic phenomena. Data from such a probe would be revolutionary, providing unprecedented insights into the dynamics of a gas giant's atmosphere. It's like sending a submarine to explore the depths of Earth's oceans, but on a much grander and more extreme scale. The challenges are significant, but the potential scientific rewards are immeasurable. Section 3. A telescope's gaze. Observing from afar. While spacecraft missions provide the most detailed views, we can still learn a lot about the Great Red Spot from afar. Future generations of telescopes, both on the ground and in space, will have the resolution and sensitivity to observe Jupiter and its iconic storm with incredible clarity. Imagine a telescope so powerful that it can resolve details on Jupiter's surface just a few hundred miles across. Such a telescope could track the movement of individual cloud features within the Great Red Spot, monitor changes in its size and shape over time, and even study its interaction with smaller storms in unprecedented detail. These observations, combined with data from spacecraft missions, will provide a comprehensive view of the Great Red Spot's behavior and evolution. By studying it over long periods, we can track its response to changes in Jupiter's atmosphere and gain a deeper understanding of the factors that influence its longevity. It's like having a time-lapse movie of a storm that's been raging for centuries. Section 1. A timeless marvel. Jupiter's Great Red Spot is more than just a storm. It's a symbol of the enduring power of nature and the boundless wonders of our universe. For centuries, this swirling vortex of crimson clouds has captivated our imagination. From early telescopes to Juno, we've come a long way in unraveling its secrets. The Great Red Spot is a high-pressure anticyclone driven by Jupiter's rapid rotation and internal heat. It's a swirling maelstrom of winds, yet its center remains strangely calm. Despite its massive size, the Great Red Spot is shrinking. The Universe Beckons. The quest to understand the Great Red Spot has driven innovation in telescope technology and spacecraft design. It's pushed the boundaries of what we thought was possible and inspired generations to reach for the stars. and it's a testament to the power of human curiosity and our desire to explore the unknown. The Great Red Spot is a reminder that we live in a universe of boundless wonder and endless possibilities.